welcome to this presentation about the SolidWorks and ANSYS Workbench. This is going to be an introduction to both these software programs, mainly because the integration that we have between SolidWorks and ANSYS works relatively smoothly. A couple assumptions up front for SolidWorks. I assume you've already had a basic working knowledge of SolidWorks. If not, this will be might be real quick for what you're experiencing, but hopefully it's more of a refresher for how to interact and do things in SolidWorks. And then some specific things how SolidWorks works with ANSYS. I expect when we go into ANSYS Workbench, it'll be the first time for you, so I'll take my time going through that. But I just want to give you that heads up front of what we're doing here. And all we're doing this time is just working through a problem. So here's a problem for several parts shown below. They're all very similar. Let me scroll down here so you can see them. All right, so just variations on a theme. All right, so very basic shape here to start. So for all those parts, units are in inches. Determine the design which best relieves stress. We want to make the original part have a small radius of 0.1 inches at the inside reentrant corner, so right here where the hand's at, in both these locations. So if it has those reentrant corners, it's 0.1 radius there, and if not, it won't, like in this case. Place a uniform pressure load of 1,000 psi on the right end of each part and fix the left end. So fix the left end here. All units, again, are taken in inches. Let the material be structural steel. All right, so we got the modulus and the Poisson's ratio for that. And the thickness of all designs to be 0.5 inches thick. So that's the dimension coming out of the page. Again, oh, sorry, I didn't mention, if you go down into the notes, there's a link to the Google Drive folder, which has us in the notes folder, subfolder of that. So you can access and get this, which would be good because I'm not going to refer back to this. I have a copy next to me, and so that's what I'll be going off of and looking at dimensions. We're going to be looking at developing this one, this particular design. I'm going to call it Design 5, Part 5, during this lecture. So if you want to follow on, that's specifically what I'm going to look at here. Just to highlight, as before we get started, this should be 0.125, so I didn't get the actual all three digits showing there, and I'll show you how to do that in SolidWorks. Also, here at the bottom, it'll summarize what we're going to do. I'll zoom out here. It's going to summarize what we do to import into ANSYS. So we're going to go through all this process here. The biggest thing to note as we do this is the kicker here. So at least the license that I'll be using, which is the introductory teaching license, so CFD Mechanical teaching license, we're restricted to 256 nodes. Now we're not going to go anywhere close to that this time. But just to note, for those of you using an educational piece of software, you're restricted there. All right. So again, feel free to look at these. I'm going to zoom in here, get a better idea what we're looking at here before we jump into SolidWorks. So we have the overall structure of the main one that was looked at up top. We're going to have this. We want the 0.1 inch radius fillets here. And then we have two holes, relief stress holes here and here. And so I'm going to basically use some symmetry, exploit the symmetry we have in this. So draw this top half, this being the symmetry line here, and then we'll mirror image across with that. All right, so let's get into SolidWorks. I already have mine loaded up here. And so when you first enter SolidWorks, just need to create a new part. So I'll go up here to New. And kind of best practices, I think, we got screen real estate here, so most people have a wide screen. Usually this initially this menu is hidden in here. And you come up here and it flies out. You got so much real estate on top here. I just pin this down so you can have easy access up here. You also want to make sure if we're going to use the SolidWorks integration with ANSYS capability, you need to see an ANSYS menu up here. If you don't, it may be because you need to go into add-ins. And we'll wait for this to come up, and then at the bottom, you'll see, hopefully see ANSYS 15. Now, some of it, there might be an issue with needing to install it. Once you have SolidWorks, it could be various things that are happening, and so I can't really help you troubleshoot that. But you should see that there. If you don't, there is another way, really easy way to get around it, but it just makes things a little bit quicker to integrate. So I'll show you both ways, and we'll be good there. All right, so let's create a new part. Click on New, and this part looks good, and click OK. Wait for the new screen to come up here. There we go. So we're going to start with doing a sketch. So come over here to Sketch in the ribbon. and go ahead and click on sketch. And we need to pick which plane to draw on. We'll just go with the front plane, so I'll click there. And so whenever you're doing SolidWorks drawings, you just want to draw. Just draw it off, draw the general shape, and then we'll come back and we'll dimension to get it cleaned up. So actually I don't want to start on Smart Dimension. I'm going to start on line. So click on line. And I'm going to make sure I get the origin here, coincident with the origin. So click, and I'm going to draw, but I'm going to just get the general shape of what I'm trying to draw here. So I'm just drawing the general shape here. Now when I come down here, I want to see it that it's in line here with the first point that I made. So click there, and I hit escape. And so this is what I'm going to do symmetry on. So I want to create a symmetry line. Well, let me wait. I'll come back to that. So let's dimension this as we have it. So do Smart Dimension, and I'm just going to click right on that line. Make sure you get the line. And oh, see I'm in meters here. Now everything that on the sheet, everything it said on the sheet, everything is in inches. So let's get ours in inches. So I'm going to escape out of this. I'm going to change the units over to inches. So get out of dimensions here. So escape back here. And we'll get this fixed when we do. So let's go up to get the units. So if you come up here, and I'm just left clicking here. I'm going to go into options. All right. And I go into document properties. And you come in down here to units. All right. And I want to pick inch, pound, second, so I can get the inches for my dimensions. That looks good. Now another thing you could do here is if you have a number of sig figs you want to see when you're typing in dimensions, you might want to come up here and change this primary precision from just 2 sig figs to something more than that. I'm going to just leave it at 2 because most of them are just fine, and then we'll do the ones that need to be more, and I'll show you how to do that individually. So I'm just going to leave that there, but the biggest thing here is making sure your units is what you're mostly going to use, and we're going to go with inches. So I'll go with OK there. You can also access this menu through Tools. Here's being a little slow here. Let's go to Tools, and my screen's blocks this here. So again, here are those 3 options that are in that drop-down menu that we used before. So add-ins, customize it options. Okay, so let's fix up this dimension here. I'm going to click on that again, and it's got me at we're at here 0.9. I want that to be a ½ an inch, right? Because I'm doing the symmetry, so I'm only doing the top half. So I'm going to do Control A to select all, and 0.5 to give me 0.5 inches there. That looks better, so I'll check that. Dimension here. Oops. Gotta get my Smart Dimensions, so I'm going to click on Smart Dimensions up here. So I click here, and I do 3 inches there. So 3 inches there, and we'll do 3 inches up here while we're already in that area. So 3 inches, enter. This little side here, it's only 1 inch. So I'll call that 1 inch. And green check that guy. And over here you can see it looked like we had this point was going to be in line with this one over here, but it's not. So let's come back here and make this what it should be, 1.5 inches. So that should be good to go there. So I think we got everything well defined. Let's come back in here and let's get that radius going. So zoom in, zoom all maybe. I'm going to scroll the middle button. I have a middle scroll wheel. So I'm going to zoom in here so to get that. And now when I put my little radius in here, a little fillet. So I need to come up and get my fillet feature. So sketch fillet. So entities to fillet. So I'm going to fillet this entity and that entity together, and it gives you kind of a preview. And I'll go ahead with the 0.1 inch that it has here as the default, because that's what it says in the handout to do. And go ahead and green check that guy. So that looks good. All right, I still got 2 holes, so let me go back to the drawing. We'll highlight those. All right, so we got these 2 holes we need to drop here. So those are just cuts, basically like a drill press drill that they went through the part here. So we want those to end up being holes. So we just need to draw circles for those and locate them correctly. So coming back here, we're done with this sketch fillet feature. All right, so let's just put in a couple circles. Again, I don't care where I put them. I just want to put them in there, and then I'll dimension them afterward. The second circle, again, be careful you don't get coincident with anything. So I'm just going to put out here in the middle. Looks good. All right, so now I'm going to smart dimension these guys so I can put in the radius. So this one is the one I said was 0.125. Now if I hit enter here, watch what happens. All right, so my dimensions, the sig figs is only set to 2 sig figs. So I actually want to see that as 3 sig figs. So when you come over here to the right, left-hand side, right here, the document is set to be 2 sig figs. I'm going to change this one to be 3 sig figs. All right, so then I see over here 0.125. So that updated what I want it to be there. So check that off. Do the radius on this guy too. Oops, Smart Dimension got turned off there. So click on that one, and that one is 0.5. 0.5 there for the diameter. All right, so that looks good. So obviously it's too close to there, but again, the dimensions will fix that. So let's kind of just keep going with that. We'll click there and here. And I should probably zoom out a little bit. So that looks good right about there. And that one is 0.0375, 3/8 of an inch. Oh, and that one's kind of hidden there too. So let's go 3 sig figs there. That looks good. All right, let's go do the circle so it doesn't get out from underneath the other one. And we'll do, that one is at 1.0625. All right, and so the sig figs there. That looks good. And then we got the dimensions here from the top line. So again, I'm just clicking on the point here, and then I'm clicking on the line. Get that dimension distance there. So for the big circle, it is, again, 3/8 of an inch, 0.375. And up the sig figs so I can see it. And we got the other last one here, and we get that one to 0.1875. 0.1875. And show 4 sig figs for that guy. All right, so that looks good. Let's zoom out. Oh, let me just zoom the whole thing here. All right, it's kind of a mess there, but as long as the dimensions are correct, we should be good in location. All right, so we're ready to get the mirror image of this. So let's set up our symmetry line or center line. So we'll come here to line and select center line. Line would be fine, probably by itself, but just to be safe, we'll do center line here. So start at this point here, because that one's at the right location. Come over here, select that point, and escape. So that looks good. So now we can come over here to mirror entities. And entities we want to mirror are everything above that line. So let's just select everything. And then we'll take whatever this line is here, and we'll unselect that one. So I believe that's line. Oh. Been selected for us, so I think we're good there. So let's go mirror about our center line. That looks what we want. We'll green check that one. Oh, an issue down here. So it says it's overdefined, right down here in the right at the bottom here. So it's overdefined, and I think what happened is the center line helped lock us in this point right here. So it's saying we don't need this information here on this dimension. So just go ahead and click and delete that, and that cleans us up there. All right. So it's because basically this line got coincident with this line, which is told to be horizontal, so it knew which dimension or what the distance was already, and having an extra dimension on there overdefined it. So everything's good, everything's resolved. Looks good. So let's go ahead. We don't even have to exit the sketch, just leave that there. Click on Features and Extrude Boss Base there. And we'll go ahead with the blind sketch or blind extrude, and we'll go 1/2 inch, so 0.5 inches. And we'll green check that guy. All right. That looks great. Right, zoom around, so I'll just middle click and move my mouse, or you can middle click and hold down control actually, sorry. Oops. Hold down control, middle click, and you can pan, move it around, and zoom in and out again with the scroll button in the middle. All right, so we're all ready to go. So if we want to take this into ANSYS, actually anything we want to do to get this over to ANSYS, we need to save it first. So you can run into issues and it just won't show up and stuff like that. It may or may not give you errors to help lead you in that direction. Easiest thing to do is just save this. So I'm going to go ahead and save it as part 5. So this was the 5th one on the sheet. I'm going to save it as part 5. Oh, I already have it in here. Look at that. I just have it in my downloads folder because I can save this for next time. But anyway, save it to your favorite folder, whatever name you want to give it. We'll save this up so we can replace it there. All right, so it's been saved. And so if we want to take it directly into ANSYS, if we have this menu up here, we can take it in. It's just come up here with ANSYS Workbench and click on that. And ANSYS isn't loaded. I didn't have this loaded already, so this is loading it on my machine for the first time here. So it's loading up the Workbench project page. So this is where we kind of add things or kind of connect things where we want things to happen. So what it did, it loaded in the geometry, in just plain old geometry box. So they're not going to do any analysis with this as it's shown. It's just straight up just geometry by itself. So we need to tell it what kind of analysis we want to do. And for this one, because we're going to be loading with pressure and just looking at the overall structural analysis to it, this is a static structural analysis. So here's the analysis here. So we just need to click and drag it over. It shows you the different possible ways you can drag it. We'll just drag it right here. Let's create a standalone system and let go. Let go of the button. And it'll load in here. And it's going to already have pre-populated with the engineering data, and I'll show you what that is in a second. But the thing we want to do is, because this brought it in directly from SolidWorks, we want to click and drag it over onto the geometry, and that'll connect it up like that. Now the other thing I said was we could do this without having any ANSYS integration with SolidWorks. So if we do it in some other software program, or we have it in SolidWorks, we already did it and we saved it, and now we just want to open ANSYS by itself, we don't want to have this automatic integration piece, that's fine. The way we would do that is we bring in the static structural like I did just now, and I'd right click on geometry, and I'd have replace geometry, and it's already connected here. So let me go over here. This will be functional, be available. Now let me just do it like this. So I'm going to delete this, delete the link so you can see here. So right click on geometry. Didn't like me right clicking twice, I don't think. All right, so now we want to replace geometry. And so we can come in here and browse and find our part. So you can still just save it in SolidWorks, bring it in here if you don't have the integration set up right. But just, again, right click on geometry and just come in here and you can draw in here. ANSYS also has Design Modeler as its own 3D modeling program. I think it's extremely clunky. It's great for really small geometries you want to do, and maybe some specific ANSYS conditions or setup pieces are nice to do with it, but it's usually best to draw it somewhere else and then bring it in to finish it off in ANSYS. All right, so I'm going to reconnect that up here. So we have it from the original thing. All right, now I said I was going to go back into engineering data. Let's do that. I'm just going to double click on engineering data. And so what it is the data, what kind of materials are we going to bring into the analysis? And so this one is showing that structural steel will be brought into the analysis. And if it's already highlighted, so click on it without changing the name. I come down here and we can look at the Young's modulus is 2 to the 11th pascals. All right, so we're expecting a structural steel with a modulus of 29 times 10 to the 6th pounds per inch squared PSI. So let's come in here and change the units to make sure that's what we got here. So there's PSI. And we got 2.9 times 10 to the 7th. Yeah, so that's 29 times 10 to the 6th PSI. So we're good there. This will work. If you want to add another material, you can come over here to physical properties. These are things you could define specifically, but if we wanted to look at adding a different material other than structural steel, we could click here to add a custom material. Or probably the easiest thing is come up in the data sources. So I just clicked on data sources. And here's one that can be used a lot, so we could just click on add. So you'll see the book up here next to it. Other things, if we drag this down here a little bit, let's look at some general materials. They pop up here. Aluminum is often used, so aluminum alloy, click plus there. So those all look good. So anyways, once you've added them all, now you can click on engineering data sources. It'll hide them, and they'll show basically the 3 here. All right, and these will be the 3 that it brings into your model as available materials that you can use. I'll show you how you can pick those once you get into the analysis place. But it doesn't mean you have to use them. It just means they're available. So those are there for the next time we go into our schematic. So I'll go ahead and close this. Everything's already saved. And now ready to go into the model. I'll double click there. All right, and there's my model. And I can click, left click to select different spots. I can middle click and rotate. So similar features to SolidWorks. All right, I can right and middle click, or sorry, control, middle click, and pan around. And if you want different views, probably the quickest way is to right click and go to isometric view. You can get that view. If you want to get one of these face views, the nice thing to do is come over here to the triad and click on which face you want to view. And you can click and see the different faces very quickly. And you can see how it's positive Z. If I come down here, I can get negative Z. If I move slide down there, so I get the negative Z. And this little ball here is the ISO, so I can go back to ISO view. So ultimately, I want to look at what's happening on the orthogonal to the Z plane or Z axis. So I'll click on that one. And maybe zoom out a little bit so I can still see my scale at the bottom. Zoom out in pans. Let me get back here. Zoom out and I'll pan it up here a little bit. There we go. See everything okay. What we're going to do is we're going to work our way down this tree on the left-hand side, our outline. So you can expand the body. Here you can see that part 5 is there. What I want you to notice when I click on part 5, I can come down here and define a material assignment. So it's already set to structural steel, but I also selected air and aluminum. So if I click on structural steel, I can see here that I have air and aluminum alloy. Now I can also add a new material. I can import. I can edit structural steel. But here's how I can access, apply those back there with engineering data, and then I can come in here and select the ones that I want to use. So I'm going to keep it with structural steel, so that looks good. And come in here, and we got to start putting on boundary conditions on this thing. So let's come here and click on stack structural, because that's the type of analysis we're doing. So it wants what kind of boundary conditions for that analysis. And so it brings up here what's available. So I can do some different types of conditions, supports, loads, and inertial aspects that we can apply to it. So from our handout, we know that we want a fixed support here on the left-hand side. So let's turn it over so we can access that panel. And we can click on it now, or we can click on it once we've done the support here, but I'm going to click on it first. And I'm going to come here and I'm going to say I want to apply a fixed support to that. So I'll click on fixed support. And you can see for the geometry selection, it says you've already have one face. So it's already got fixed support applied to this purple face. And that's all I need to do. So that guy's all set up and ready to go. I'm going to do a little bit differently for the next one. I'm going to go to the loads, and for the pressure loads, that's the other side here. So I'll click on pressure. And so now it's asking me, hey, where do you want to apply it? Which face do you want to apply? Because I didn't give it one. So let's rotate it over, and I'll select that face. Now it's still not accepting it because I haven't applied yet. So you got to make sure once you select it, even though I'm already in the details of pressure, I need to apply it so it captures it. And you can see the color change kind of indicates what's going on there. All right, direction looks good. I want the pressure to be 1,000 psi. So I can do 1,000 there. And hit enter. That looks good. Ramp, that's fine. It'll get up to it and it'll show me the ultimate stress that's been applied to it or caused by the pressure force. And we could do the mesh. So let's look at the mesh here. Coming back to the mesh, we can just go ahead and update. And we can also right click on mesh. You can hit update or generate mesh. So go ahead and do that. So generate mesh. So you can see a very, very, very coarse mesh. We want something definitely finer than that. So we'll come in here and we'll do the relevance center. We'll go from coarse to fine. And now it says the obsolete mesh because we just updated the relevance center. And we'll come in down and update the mesh. All right, so that looks better. Let me see what we got here. Oh, got a warning. All an update. Expected errors occurred. Oh, I was trying to do something else at the same time. All right, we're still good. So we can come in here. Oh, by the way, just what was showing there. So we got this. The messages shows you, give you some idea about what errors are due to. So it's kind of a nice feature. Sometimes it's helpful, sometimes it's not. All right, so come back here. I'm going to do statistics. Kind of see how many nodes we have. So again, this particular license, we're restricted to under 256,000. So we're not even close to that at 33,810. So we'll be good with what we have. And we'll just start with this. In future presentations, we'll talk about how we can refine the mesh and where we want to do that. All right, so that looks good. So I think we're ready to solve. So we'll just come down here to solution and go ahead and right click. Right click on solution and solve. There's also solve up here at the top. That was yellow at the time before I clicked on it. All right, so there we are. Solution's all done. We can't see anything, right? Well, we didn't tell it what kind of plots we wanted to see. So we come up here and we say, hey, we want a total deformation plot. I don't care about particular direction. I want to see the total deformation. So I'm going to click on that one. And I also want the equivalent von Mises stresses. So look at that. That's going to be my comparison between these different types of parts, how much stress they show. So click on that one. All right, and it's got these lightning bolts, which says we don't actually figure these out yet. We don't need to resolve it. We just need to evaluate the results from it. And so there we get the overall deformation that's happened. So that's the overall deformation. So we get 0 to 0.0046. We don't know what units there are because they're up here. So that's in inches. All right. So make sure we see the units displayed there. And we can see the distance here on the, well, I guess you can't really see. It's probably exaggerated a bit. Equivalent stress, we click on that, and we can see the equivalent stresses that are showing up here. So we get up to a maximum of 6,600 psi, and probably happening right in there. If we want to see where that max stress, we can come up right here. Nice little quick way of pointing out the max stress. So it's finding it here on the bottoms. That's probably symmetrical, it's right up in there too. All right, and we can look at the minimum stress being there at the corner, not affected much by the pressure force being applied. All right, another nice thing to see here is on the animation piece. So it said that I had a ramped pressure force being applied to. You can hit play and you can see what happens in that in the time that it applies the force. See how the stress gets distributed throughout the piece. All right. So just one other feature I want to show you as you do these. So you can go ahead and save this if you want. But usually if I just go ahead and close this, it'll save the results. And I can go back and ANSYS project. And if I double click, so it sees all the way, the green check marks kind of just follow that path. So it already has the results still saved in there. So I double click, I should be able to go back in and have my results there. Click on equivalent stress and it pops back up. All right. And again, if I want to, I haven't actually saved this to a particular location, so I'll come up here and save project. And again, I'm just going to do it in my downloads folder and say my, this is going to be part 5. All right, save. All right. The other nice thing about this integration piece, so watch what happens if you come back into SolidWorks. And so here's my overall part. And if I go back to my sketch, and what if I change my sketch and I say, you know what, I really didn't want this circle right here. I'm just going to delete that. Delete that circle. So let me come in here and edit my sketch. So edit sketch. And find my circle. Click on that. And delete that. So it's gone. And update that. So this hole stays. All right. That's fine. And I'll save it. And now let's go back to ANSYS Workbench. And if we come here to geometry, let's right click. And you'll see this in a couple of different places, so I just want to make sure we try these. So we're going to update from CAD because we updated it and we saved it. So now it should be updating into the model. So let's see what happens when we go back into our modeling software after it's updated here. Oh, look at that. So I got a bunch of lightning bolts here. So it says, okay, something has changed, so you need to rerun your model to update. So we'll go in here to model. Needs to be upstream data needs to be reread. Would you like to read the upstream data? Yep, because we updated our geometry. So wait for it to start up mechanical, ANSYS Mechanical again. All right, so there we are with our hole there, and let's zoom so we can see the side there. All right, so we just have to rerun this, solve this again. And look at our equivalent stress there. Right, so now we see a max stress shown up here, a little bit higher than it was the previous time at 6,600. All right, so you can save this and do that. Another thing I just want to show you here, there's another update option here in part 5 where you can make sure I get the right spot here. It's right there. Yeah, so you can update geometry from source there as well. And let's just see if that works as expected here. So we'll come back in here, edit our sketch. Let's delete the other circle and confirm that. And we'll save it. And come back in the design modeler and see if we can get that to update from source. All right, looks good. So yeah, so now you can just stay in ANSYS Mechanical, go back to SolidWorks real quick, make a design update, and come back into ANSYS really quickly. So that's kind of the nice piece of that integration. All right, and some of that might not even need the piece that this piece here. I think it'll still work, but if you just had this block and brought in your geometry right here. All right, so hopefully that gives you an idea of how to create and analyze your own model in SolidWorks and analyze it in ANSYS Workbench. If you have any questions, let me know in the comments below, and I hope to see you at the next presentation. Thanks.